Welcome to this video covering typical exam questions for EBN. So we are going to go through a couple of questions, or a lot of questions, about 3 hours worth of questions, and we're going to solve them, and yeah, basically. So our first question is that you have a power supply with a terminal voltage. So you got a power supply with a terminal voltage of T squared V, and it delivers a constant current of 2 amps to a factory machine. Determine how long the machine was on for if it is known that it has consumed 114 kilojoules of energy during this period. So for you are given energy and you are asked to determine time. So power, energy is the integral of power, and power is voltage times current. So energy, work done, energy, potato. So this is the integral of power, which is equal to the integral of VI. So you are given T squared 2 dt, which gives you 2/3 T cubed, and your conditions are to find your value of T starting from 0. So for you to get the time, you equate the work to the 114 kilojoules. So 114 K is equal to 2/3 T cubed, and T is equal to 60 seconds. The next question says that you have 40 minutes to bake 4 trays of muffins in a 7 kilowatt oven. Each tray has the capacity of 9 muffins. How much does it cost to bake 180 muffins? Assume electricity costs 15 cents per kilowatt, and that the oven is always used at maximum capacity. So first of all, you need to determine how many kilowatt hours were used and then multiply that by 0.15 to get the cost, right? So to determine the kilowatt hours, you must first change your time from minutes to hours. So the time is 40/60 hours. And then you are told that you've got your 4 trays which have 9 muffins, so therefore you can make 36 muffins at a time, which is just 9 by 4. So therefore the number of times you need to repeat this process is equal to 180 divided by 36, because you want to get to 180, right? This means that you have to repeat this process 5 times. So by multiplying the number of times you repeat the process by time, you can calculate the total time, the hours part, and then the amount of kilowatts is just multiplying by the power of the oven, the 7 kilowatts, right? So then your cost is equal to your 0.15, because it costs you 15 cents per kilowatt, multiplied by we're going to be doing this process 5 times, and we have a 7 kilowatt oven, and each time takes us 4/6 hours, 40/60, 4/6. So this gets you to your cost of $350. The next question we are going to look at says we must find the power associated with a dependent voltage source if I1 is 2 milliamps and R2 is 2 kilo ohms. So you're given I1, which means you know the value there, which is 10, and you have 2 equal resistors, so therefore the current is going to split equally amongst them. So you've got 5 amps going through each node, and the value of R2 is 2K, so the voltage is equal to 5 multiplied by 2. Oh, I forgot that this is in milliamps, because that would have been a weird mistake to make, having 20,000 volts across. So that's 5 milliamps, my bad. And this is equal to 10 volts. So now you know the value of V2, and you can now use that to substitute into there. You know the voltage across the source, you know the current going through it, so now you can calculate the power. So your power is equal to I1, which is 2M, multiplied by the voltage, 10 multiplied by 10, which is 0.2 watts. So the next question says we should find the power associated with the resistor R1 if V2 is equal to 0.5 volts and R1 is 1K. So you've got a 1K there, and you've got 10 multiplied by 0.5 means you've got 5 volts here, right? So in your system you have a negative 5 volts here, and on the other side you have a positive 15 volts. So therefore your voltage across the resistor is 20 volts. So V1 is 20 volts. So you know V1 and you know the value of the resistance, so you can use your power formula, which is equal to V squared over R. So you've got 20 squared over 1K, which is 0.4 watts. A 30 volt voltage source is connected in series with 2 resistors, R1 and R2. Calculate the voltage VR1 across R1 if the resistance of R1 is half the resistance of R2. So R1 is equal to 1 over 2 R2. So V of R1 is equal to half R2 over half R2 plus R2 multiplied by your voltage source, V of S, your 30 volts. So this is 1 over 3 multiplied by your 30 source, 30 volts, giving you a voltage of 10 volts. 30. So the next question says determine R if R equivalent is equal to 30 ohms. So looking at this, you have one node there, a second node there, and a third node there. So you can see that these two are in parallel, and your result of those two being equal means that you've got a 1 over 2R there, because of R being parallel with R. So then now we can erase that and have a half R there. Now we can see that half R and R are in series, as seen here. So then your result is 3 over 2R between this node and that node. And now you have your 3 over 2R in parallel with 60. So therefore R equivalent is equal to 60 in parallel with 3 over 2R, which is 60 multiplied by 3 over 2R over 60 plus 3 over 2R, and that is equivalent to the 30 ohms. So solving this, you get R is equal to 40 ohms, whether you decide to do it by hand, simultaneous equations, or you use the calculator method. This is the next question that we will be doing. So they say determine the equivalent resistance R of CD with respect to terminals CD. So that leaves us with no current flowing through A or B, because A and B are not even connected to the circuit, so no current can flow. So that simplifies our circuit to just this. Okay, so you can see that the 35 and the 25 here are in series, giving you a total equivalent total resistance of 60 there. And then now we'll just look at the nodes. Should have actually started by doing that first. So by doing that, you can see that the 60 kilo ohm resistance is in parallel with the 20 kilo ohm resistance here. So what happens? Why that color? What happens is that you have your 20K and your 60K, right? So you can notice here that there is a ratio of 3 dividing 60 and 20. So you can simply say that your R equivalent is equal to 60 over 3 plus 1. The ratio between them plus 1, given that the ratio is a natural number, like a full number, not like fractions. So this gives you 15K. And yeah, you can do the equivalent formula and say that the result is the same. So this is like a quick trick you can use if you can see it. So after doing all of that, this reduces our circuit even further to the point that that is gone, and this is 15. 1, 5, 15. So now you can see that your equivalent resistance is going to be equal to 35, which is R of CD is equal to 15K plus 20K, which is 35 kilo ohms. The next question says, use nodal analysis to set up two equations of the following form. So by looking at this circuit, you will see that you have a supernode going on here. So V2 minus V1 is equal to 2IO, right? So what is this current IO? How can we calculate it? So the current IO is the current that is going through this the 10 ohm resistor there. So to determine the current IO, we need to find the voltage that is across the 10 ohm resistor. So we know that there's a potential difference of 30 volts here. So therefore, if this is V2, using 30 volts is equal to V plus minus V2. So therefore, V plus is equal to 30 plus V2. So now we can calculate the current I of O, which is equal to V plus over 10, which is 3 plus 0.1 V2. So now you are able to substitute this into I of O. So reconfiguring the equations, if you have V1, it has a coefficient of -1, and for V2 you got a coefficient of 1. This is equal to 2 multiplied by 3 plus 0.1 V2. So this leads us to having a V2 which is equal to 0.8, and that is equal to 6. So now to manipulate this equation to look like the first one, you need to have a minus 60 on this side. So you need to multiply by -10. So you got 10V1 minus 8V2 is equal to -60. Or you could have chosen to use the second one, multiplying by +5 to get C and D. But at the end of the day, there's going to be two sets of equations, and the order you put them in doesn't matter, or you'll be told that this one comes from this. But it doesn't really matter, because the system is going to mark two sets. For the second equation, we need to do the supernode equation. So you have, starting by looking on this side, you've got V1 over 5, and then you've got V1 minus V2 over 25. That's the side for V1, and then from V2 you've got V2 minus V1 over 25, and you've got V2 over 20. I had almost forgotten that this source here, which is a voltage source, can also be seen as your source transformed current source, like that. So you've actually got a current here in the form of 30 over 10, which is your 3 amps. And then by doing a source transformation, this means that now you can see this resistor. So we need to just add one more V2 over 10, and this is because our current is flowing out of the node, because remember, with our nodal analysis we are assuming that the currents are flowing like this, and this is flowing in that direction, so that's why it is on the positive side. All of that is equal to 0. So something you have noticed is that you get this resistance, the 25, it cancels this one that's shared, because both sides of the node are interacting with it. So by grouping our coefficients together, we have V1 into 1 over 5, and we have V2 into 1 over 20 and 1 over 10 from the 20 ohm and the 10 ohm there. And this is equal to -3, taking it to that side. So for us to get this equation in terms of that, you have to multiply by -10. This gives you a coefficient of 2 for V1, and you have a coefficient of 1.5 for V2, and this was -30, or the one in positive 30. Okay, so put a positive there and multiply that whole side by -1, and that is the other equation. So the next question says that we should use mesh analysis to set up two equations in that following form. So you got 3 meshes, but they want 2 equations, but it doesn't have I1. The reason for this is I1 is -2 amps, because I1 is flowing in this direction and the 2 amps is flowing in that direction. Okay, and here you've got a super mesh there. So you've got I3 minus I2 is equal to 4. So that's for G and H. Okay. Oh, they wanted I2, I3. -I2 plus I3 is equal to 4. And then now the enormous equation. So you've got, for I2, you have your 10 ohm and your 8 ohm, which is, so you have 10 ohm there, and then you have I2 minus negative 2 amps being multiplied by 8, and all of this is just 10I2 plus 8I2 plus 16. So for the second mesh, the I3, you have I3 plus 2, as we established there, being multiplied by 12 minus 15. Right. So by putting the two equations for the two meshes together, we have to solve to find F. So this gives you the result of 18I2 plus 12I3 is equal to negative 25. So this is the next question we will be doing. It says calculate VO using either nodal or mesh analysis. So when you look at this, you'll realize that there is one node and there is your second node, right? So obviously your one node is grounded, so you only have one node. So why would you want to do anything but nodal analysis? Nodal analysis is always the boss. Always choose nodal analysis, because nodal analysis is the best, in my opinion. But there are places where it doesn't work, but usually nodal. So to use the nodal, we are going to have to source transform these into our current sources. So that will be a current source of 30 over 20. And here, oh, this one is in the opposite direction. And there you have a current source of 5 over 10. So now it is very simple for you to calculate VO, right? So that's gone. That's gone. So you have VO over 5 for here. Then you have VO over 10 for this resistor. That's plus. And then you have your VO over 20 for that resistor. And then looking at your current sources, here you're going to have negative 1 over 2 VO. Our 5 over 10 is 1 over 2. Plus 3 over 2 is equal to 0. So by simply grouping the coefficients together, switching that to that side, and dividing, you can get the value of V of O is equal to 10 volts.